Sadly, this is the last video from this section, but the good news is matching graphs to functions is pretty fun, okay? Can't spell functions without fun. So let's look at this function. We're going to ask you a bunch of questions, putting a bunch of things together like we did at the end of the polynomial section too. Put a bunch of things together and then use those things to match graphs to functions. So what are the intercepts? Oh, we just did that. That was the last video. Feeling good on that, hopefully. This would be a great opportunity to pause the video and try to do these on your own, is what I'd really recommend. But if you want to do it with me, that's fine too. All right, so the horizontal intercept, or the x-intercept, is when y equals 0. That's going to be when 0 is 6 times x minus 1 all over all that stuff. Okay, multiply both sides of the denominator. They don't share any factors, so there's no holes. That's going to be when 0 is 6 times x minus 1. Okay, that's true when x is equal to 1. And the y-intercept is when x equals 0. So when x equals 0, the function evaluated at 0 is 6 times 0 minus 1 all over 0 plus 2, 0 minus 3. That's negative 6 over negative 6. Okay, when y is equal to 1. So our intercepts are when x is equal to 1 and y is 0, and when x is 0 and y is positive 1. All right. Great, let's do B. Find the asymptotes and if there are any holes. I haven't found a lot of holes so far. Holes, remember, if they have the same factor and the top has at least the multiplicity of the bottom, they don't have any common factors, the top and the bottom, so there's not going to be any holes. We're going to have a vertical asymptote when the denominator is 0. That's when x is negative 2 and x is positive 3. These are vertical lines. X equals a number is always a vertical line. So these are our vertical asymptotes. What about horizontal asymptotes? Well, we need the long run behavior to answer that question. Specifically, we need the long run behavior of the ratio of leading terms. The leading term on the top is a 6x, and the leading term on the bottom is an x squared. Again, it's always just going to kind of have to look at the biggest terms. Or you can distribute this and FOIL out the bottom. Okay, and that's another way of finding those leading terms. There's a shortcut. This is the safe, longer method. So what is the long run behavior of this? Well, as long as x is not equal to 0, these two things are the same. Because if x is equal to 0, it doesn't make sense to talk about any of this stuff. And yeah, long run behavior, 6 over x. Oh, so we know what's going on here. Right? As x goes to positive infinity or negative infinity, right? As x gets really, really big, we're dividing 6 by a really, really big number. You divide 6 into infinitely many pieces, each piece is going to be basically 0. The function is going to 0. If the long run behavior of a rational function is going towards a number, that's going to be a horizontal intercept. Or sorry, a horizontal asymptote. It's when the y value equals that number. In this case, it's 0. So let's combine all this stuff. See if we can answer C. Well, it's kind of hard to see a little bit. What does it look like? Let's start with the intercepts. Here it looks like there's an intercept at 1. Do we have an intercept at 1? We did. Okay, so maybe that's legit. Here the intercept is like a little bit more than 2. No, our intercept was at 1, 0. So it's already out. Can't be this one. It's got the wrong intercept. Here it has an intercept of 1. Okay, believable. What's going on over here? There is no x-intercept. All right, and the y-intercept, we're counting by 5s. The y-intercept is maybe 5. Oh, that's too big. Yeah, this doesn't have the x-intercept that we're looking for. We also need the right asymptotes. We should have a horizontal asymptote at x equals 0. That's kind of hard to see here. Yeah, it looks like there might be a horizontal asymptote at 0 here. Maybe a horizontal asymptote at 0 here. Kind of hard to see. What about the vertical asymptotes? There should be one at -2 and at +3. The -2 should have a horizontal asymptote. +3 should have a vertical asymptote. So that looks believable. -2 should have a vertical asymptote. Oh! 3 should have a vertical asymptote. Ah! This one doesn't have the right vertical asymptotes. It's got to be A. Okay. It's got the right asymptotes. Again, we can't really see the horizontal asymptote too well, but y equals 0 looks believable. And it has the right vertical asymptotes, has the right intercepts. We can't really tell what the y-intercept is, but it has the right x-intercept at least. And it certainly doesn't have the wrong y-intercept. Okay. So yeah, there we go. Check everything. Eliminate the options. That's how we can match graphs. Look at intercepts, look at asymptotes, look at long run behavior, look at everything that we just look at everything that we talked about, and then just kind of eliminate possibilities. Let me know if you have any questions. I really like these sorts of questions, so fair warning. Anyway, have a good one. Bye-bye.